this is Green, and I'm re-recording Congruent Polygons. My other one was messed up at the end. If you looked at that one and you're having to repeat, you can just go to the end. We've already got all the front stuff. So we're working with polygons, and we've already done triangles and quadrilaterals. And now we're doing any polygon will work with this congruent concept. So we've got some concave and convex polygons. A polygon has to be closed, so it can't be an open figure. That wouldn't work. And it has to have no curved edges. So if you had something like that with a curved edge, that would not be a polygon either. Like a tombstone, it looks like, huh? Okay, and you need to remember a couple of key, so you have your prior knowledge about polygons. And so I'm not going to talk in general about polygons because you've seen these for years. But we do have to remember a couple of definitions. Congruent, again, this is not new. Same size and shape. We've been talking about congruent the whole time we've been doing geometry. We can't say equal in geometry because they're not measures, they're not numbers, they're shapes. So we use the term congruent. The symbol looks like an equal sign with a sideways S on top. Corresponding is when two parts of a shape and another shape, two different parts of two shapes, parts are in the same location. So they're located in the same spot when you go from one shape to another. And if you have congruent polygons, then their corresponding parts, the parts that are in the same place, are congruent. So if you have ABC is congruent to DEF, the parts that line up, the parts that are in the same spot, A and D, those are going to be equal. So if A is on top and D is on top, those angles would be the same measure, congruent. Then, and so they're congruent if they are the same size and shape. That's one situation. Then we have something called similar. That's if they're the same shape, but not the same size. You have a baby one and a big one. And that's a little different rule. They also have corresponding parts. So you have ABC again. That's an A. And DEF. So A and D are corresponding. So they're in proportion. And it applies more to the sides. So if you look at AB and DE, those sides correspond to each other. They would be in proportion. And let's see what that looks like for an example. Okay, so here's an example of a situation where we have two congruent triangles. So we know they're congruent because they've used the symbol congruent here in the middle. So they tell us that triangle JKL, that triangle, is congruent to triangle SRT. And that means these are the same size and shape. But you'll notice that they're flipped. SRT is not oriented the same way that JKL is. So you have to match up the corresponding parts. So remember that was a word we just went over, corresponding. So I'm going to color code this. Let's use orange. And I can also tell, if you can't quite tell by looking at the triangles, the best, safest way to tell which angles line up are to look at the order of the letters. So that's not always in alphabetical order. Notice JKL is in alphabetical order, but SRT is not. So you have to look at the way the person wrote it. So J corresponds with S. So let me circle those. They're in the same order when the name of the triangle is written. And then K and R go together. And then finally L and T go together. L and T. So I've color-coded the corresponding parts, the corresponding angles. There are also corresponding sides. So let's highlight those. So I've got to match up the side that goes between the orange and the green, between J and K. I'm going to put it in yellow. And over here we have the side that's between orange and green is yellow. And let's use gray. The side that's between orange and purple lines up with orange and purple. And run out of colors, blue. So K to L, which would be green and purple, green and purple. So those are your sides and your angles, and you have to match all that up. Then they asked me to find S, And the angle that matches up with S is J. So S and J are congruent, so I don't have to do any math. If I had to figure out R, then I would have to do a calculation, because we don't know what R is. But as it stands, S and J are the same, so S would be 31 degrees. That's its corresponding part. So here we have an example of similar polygons, and we've done some work with similar polygons in the past, where we used scale factor, so this is not brand new. So I'm going to set up a proportion, and I'm going to check to see if these two rectangles are if they're similar. So they didn't ask me to do any calculation to find any unknown sides. They could have asked me that. I'm going to fill in the other sides just so that everybody's clear. These are rectangles. And now I'm going to set up a proportion. So first let me just highlight the short side and the short side of the big rectangle and the short side of the small rectangle. Those were the small sides of both rectangles. Now the big side of the big rectangle, the big side of the small rectangle. So now I'm color-coded and I can keep my facts straight. So the proportion would be 18 over 30. There are 4 ways to write a proportion. So if you're thinking, Mrs. Green, why are you choosing this way? There are 3 other ways I could have chosen. So I picked the small side of the small rectangle and then put it over the small side of the large rectangle. Then I have to go back to the small rectangle again and get the large side. So as long as you are consistent. And then there are a couple ways to do this. You could use cross multiplication, cross products property, and you could set up 18 times 40. You're rewriting the equation using the cross products property. And those, if you do the math, is 720 equals 720. So these are in proportion, so the answer would be yes. They are similar. The other way to do this is to simplify the fractions. So if I divide by 6 over 6, yeah, I get 3/5. If I divide by 8 over 8, I get 3/5 as well. So 2 different ways to check to see that these 2 rectangles are similar. Okay, example 3. Okay, all done with examples. We just have 2 practice problems. Here are 2 rectangles, and I need you to check to see if they are similar so you're going to use proportion. You're going to set up a proportion to answer the question, are they similar? And then the second practice problem are 2 triangles, and they're asking you to find angle G. So you have to, and you've been told that these are congruent. I know my drawings don't always look like they're congruent, but you've been told this is what makes it true. ABC is congruent to LMG, my personal favorite triangle, and you're asked to find the measure of angle G. That's what this little angle symbol means. Okay, that's it. Hopefully this recording worked.